Hello, in this video we'll be looking at an interesting aspect of evolutionary biology, specifically looking at how we might have evolved to detect cheats. But first, it's intro time. Firstly, I have a test for you. I know you weren't expecting a test, but stay with me, it's important. Here are 4 cards. On one side of the cards is a letter, and on the other side is a number. We can only see one side of each card. The cards we have are a D, an F, a 3, and a 7. Each of these cards will have a number or a letter on the other side. This test was actually devised by Peter Wason in the 1960s, and is called the Wason Selection Test. It's a test of deductive reasoning, and I'll explain what that is later. I'm going to tell you that if a card has a D on one side, then there will be a 3 on the other side. You have to work out which card or cards need to be turned over to see if this is true. You can pause the video if you need a little time to work it out. So, what's the correct answer? Well, I'll get to that shortly, but over 75% of people get this question wrong. To work out the correct answer, let's have a look at a different problem. Imagine you own a bar, and in order to legally drink alcohol, you have to be 18 years old. Here again are 4 cards. Each card refers to a person drinking in your bar. On one side is the person's age, and on the other side is what they're drinking. So which card or cards must you turn over to make sure no one is drinking alcohol illegally? Again, you can pause the video if you need to work it out. Over 65% of people get this one right and pick the first and last cards. I need to turn over the cards that would allow me to check if someone is breaking the rules. If someone is 16, I need to know what they're drinking to make sure it's not alcohol. The person who's 25, I don't care what they're drinking. And the person who's drinking lemonade can be any age, so I don't need to check their age. Finally, the last card, this person who's drinking beer, I need to know their age, so the correct cards to turn over are the first and the last. Now back to our initial problem. And the answer to this question is exactly the same. It's the first and last cards. I told you a D will have a 3 on the other side, so I only need to check for a card that will break the rule. Either a D without a 3 on the other side, or a number other than 3 that does have a D on the other side. I need to check the D because if the other side isn't a 3, then I've lied to you. I don't need to check the F because I didn't mention anything about other letters, so that could be a 3 or any other number, it doesn't matter. Similarly, I don't need to check the 3 card, because the other side doesn't have to be a D. I didn't say that if one side is a 3, the other would have to be a D. The statement only works one way, not the other way round. I do, however, have to check the 7 card, because a D on the other side would break the rule. Both of these problems involve deductive reasoning. In other words, reasoning from a set of statements to reach a logically certain conclusion. Now, most people find the first problem very difficult, but the second problem quite easy. But why should it be that way if they're essentially the same problem? Well, it may just have something to do with the way our brains evolved. People find it easier solving problems when they involve social rules than they do for the same task if it's purely descriptive. In the 1990s, Leda Cosmides and John Tooby argued that this was the case. Cosmides and Tooby are both evolutionary psychologists. So in order to go a little deeper, let's have a look at what evolutionary psychology is about. Evolutionary psychology argues that the human brain, instead of being a general-purpose problem-solving machine, has developed many specific modules, that is, parts of the brain, each dealing with specific tasks or problems. Each module knows its own rules, but doesn't know the rules of the other modules. The modules can, however, talk to each other to work out problems between themselves. Also, each module can only be activated when it's given information that are relevant to its abilities. Humans, just like all other organisms, are subject to evolution, and so behaviours that tend to promote survival will be favoured, and behaviours that don't will be selected against, and so will eventually die out in the population. Our brains evolved to solve tasks that our ancestors came across, and one of them was the problem of cheats. And here, by cheats, I mean someone who isn't following the rules of society. Tooby and Cosmides argued the existence of a cheater detection module in our brains, which specifically becomes active when we're posed problems in a context of social interaction and the detection of possible cheats. One of the main problems with evolutionary psychology, however, is that we can't go back in time to test these early humans, and so can't really definitely know how these people lived or the world they lived in. Let's look at an example of the cheat problem. I live in a group, and each day we all go out to collect food. Collecting food is very much a hit and miss affair, and one day, for instance, I collect more food than I need. This person here doesn't find enough, and so I give them my excess food so that we each have enough food. This is now a rule of society, and that rule is that any excess food is given to those that don't have enough. A few days later, after collecting some more food, I find I don't have enough, but the person I shared my food with a few days ago has more than enough. The rule of society states that they should share some of their food with me, and if they don't, they've broken one of the rules of society. And it's important for the group to be able to recognise this individual as a cheat. If they cheat too often, they can be removed from the group, and a group with too many cheats will ultimately disband or die. Tooby and Cosmides' cheater detection module would have some of the rules for deductive reasoning, but the module won't be activated unless relevant information regarding the detection of cheaters is provided. In the first test, the information is presented in an abstract form, and so the cheater detection module isn't activated. It is, however, activated by the problem posed in the second test, because the second test is a definite question about specific social rules. There are, however, many critics of this idea, many stating that the two problems are entirely different and can't be compared. They also argue that questions regarding a social exchange are much easier than tasks involving arbitrary letters and numbers. However, an interesting study in 2005 by Italian psychologists gave people one of two Wason Test problems to solve. Both involved the actions of other people living in an imaginary tribe. But the first did not involve any social exchange. It involved a test such as if a person cracks walnut shells, they then drink pond water. Yeah, weird, I know. The cards would then have things like drank pond water and didn't crack walnut shells, etc. on them. The second test did involve a social exchange, such as if you give me sunflower seeds, I give you poppy petals. This problem could involve the detection of cheating. They then had the people perform the tasks in an MRI scanner. This piece of equipment can detect which parts of the brain are being used for each of the tasks. They found that with the first task, which didn't involve a social exchange, 3 areas of the brain were being used. The first area is called the angular gyrus and is used for semantic tasks, and these are tasks involving the meaning of words, so no surprises there. Also used was an area of the dorsolateral prefrontal cortex, and this is used when considering lots of information at once. And the third region, the medial prefrontal cortex, is used when people have to complete many tasks but keep in mind a larger goal. Interestingly, when the participants completed the task that did involve a social exchange, the poppy seeds one, the same left sides of the brain were being used, but also the same areas in the right side of the brain were being used. This is interesting because only the task that involved a social exchange involved the right side of the brain. But has it proven the existence of a cheater detection module? Well, on the basis of this one test, no it hasn't, but it is interesting nonetheless. Unfortunately, we'll never be able to go back and test to see if a cheater detection module evolved in this way, but it does throw out some interesting ideas. This also links to a possible reason why we develop speech in the first place, but that's for the next video. If you made it this far, please consider liking and subscribing, and until next time, thank you very much for watching.